All right, hi there. This is Dr. Matthew J. Traum from Engineer Inc. This is another video to showcase a new hands-on learning module fluid mechanics laboratory experiment. This one is a hydrostatic standpipe that demonstrates the principle of static fluids and the pressure increase associated with depth in those fluids. This is part of a series of experiments that we are putting together to complement a fully online fluid mechanics class for engineering undergraduate students. This is one of many videos that I am putting together to showcase new working prototypes as I complete them. So without any further ado, let me describe to you how this experiment works. So as I mentioned, it's a hydrostatic standpipe. So what we have here is just a column of liquid water that has some height associated with it. And it's sitting in a graduated cylinder, and it's a little bit hard to see perhaps in the video, but there are little graduation marks here that indicate volume of fluid. I can take a caliper and I can measure the area, at least the diameter of the orifice of the opening there, and from that diameter, and assuming that the shape is cylindrical, I can figure out how much distance there is between each one of these little delineation marks, and that gives me an elevation of the fluid or a depth of the fluid from the top of the fluid there down to the bottom of the graduated cylinder. Now I've got a hole drilled in the bottom of the graduated cylinder right there, and I've got a Tygon tube that is a continuous tube that runs all the way up to this manifold here. The manifold has got two pressure gauges on it. One is measuring in PSI, pounds per square inch, and the other one is actually dual scale, so it's measuring in inches of water, which is the red scale, and it's also measuring in ounces per square inch. So I have three different ways, or at least three different scales to measure the pressure, and I can compare each one of them to one another. And so what I've done is I've filled the graduated cylinder up with water. The water has filled up this tube, and now it provides a continuous column of water between the water in the graduated cylinder and the manifold. And so what I'm going to do is grab the manifold, and I'm going to move the manifold up and down, and you guys will actually see the pressure gauges move as I do that. But before we do that, the first thing that I've got to do is actually purge the pressure gauges to make sure that there's no air in them, that there's only water. So let me do that for you guys. I've got just a little bucket here, one of my kids' buckets. So I'm just going to open up this valve, and I'm going to let some of the water out. So there's the water squirting out, so that water is now completely filling up the manifold, pushing all the air bubbles out. And what I'm going to do is allow this water column to fall to the point where the graduation marks start. And that, again, will give me a quantitative measure of the depth of the fluid, knowing the dimensions of that graduated cylinder. So I'm going to stop, right about there. Okay, so this is 1,800. This is 2,000 milliliters. So I've got something like 1,960 milliliters of fluid. And what you guys will be able to see as I bring this gauge back, that here, as the gauges are aligned with the bottom of this column, I'm measuring, about something almost 9 inches of water, which corresponds to just under 6 ounces per square inch. And then over here, I'm measuring just a little less than 0.5 pounds per square inch. So what you guys will see is as I move this manifold upwards, see the gauges moving? See how they're dropping? So the gauges are dropping because what's essentially happening is that the height of the column of fluid between the gauges and the top of the water column there is dropping as I move the gauges. So there they've zeroed out, so now I'll move them back down, and we will see The numbers start to increase. There we go. The numbers start to increase until the gauges get back down so that they're essentially level with the height of the fluid. Now, a key question to ask is where in these gauges do I want to align with the surface of the fluid? As I move the gauges back upwards, you notice that right about there, they look like they hit 0. And the water column is here, and the height of the gauges is a little bit below that. So there is a little bit of a mismatch, a little bit of a miscalibration between the gauges and the height of the water column. And one of the things that we will have students do in this lab is actually determine that offset and open up the gauges and do a calibration on the gauges to make sure that they're reading correctly. But for purposes of this video, I just want to show you that the gauges do in fact move as the depth of the water with respect to the location of the gauges increases. So let me see here. I'll sit this down here. Okay, so that was really the demonstration that I wanted to provide for you, just so that you could see how those gauges move as the manifold moves up and down the water column. Another thing that we can do with this experiment, right now it's set up so I actually know the height of the water, as I mentioned before, but I can just put more water in here, and I can fill it up to a point where the height of the water is actually above this last graduation, this 2,000 milliliter graduation. So there's some arbitrary height of water there. I don't know what it is. And so I can use this same method, having figured out, having calibrated these gauges and determining the height of the column of fluid and the corresponding pressure measurement from a known height of fluid. I can then actually determine what this unknown height of the water column is by moving the gauges up and down and essentially looking at what the pressure is way down here at the bottom. The pressure is going to be whatever the pressure was with the known height of water plus an additional static pressure associated with this unknown height of water. And from that, I'll be able to back out what that unknown height of water is and be able to calculate that new depth. So that's another aspect of this experiment. We're going to have the students determine an unknown water height based on what they're reading off of those pressure gauges. So anyway, that is this demonstration. Please check back as we produce more working prototypes of our hands-on learning modules for the fluid mechanics class. This has been Dr. Matthew J. Traum from Engineer Inc., and I appreciate your attention. Talk to you later. Bye.